Hey everybody, it's Mr. Millington here. In this video, we're going to keep working with our trig functions. On Tuesday, we learned how to use trig to find missing sides of right triangles. In this video, we're going to learn how to use trig to find missing angle measures. Before we get started, some important vocab first. The word inverse is super important. You've actually been using inverses for a really long time, whether you realize it or not. An inverse is just the opposite of another function. So addition and subtraction, for instance, those are inverses. Multiplication and division, those are inverses. You use those ideas when you're solving. Other important things about inverses that I wrote down here: inverse operations, they undo each other. And then the inverse can flip the input and the output. So that's really important when we're doing trig. That's how we're going to use, our calculator is going to use inverse trig to tell us missing angle measures. So when you look at these symbols here, those little negative ones, those just mean inverse. So that sign with a -1 to the x, that just means inverse sine, right? And then this would be inverse cosine and inverse tangent. So let's look at some problems and see how it works. Okay, take a second and copy down this triangle. Right here, I've got this angle right here. This little symbol right here, that's called theta. It's just a Greek symbol that we use a lot to represent angles. But we could just as easily put like an X in there or something. But theta just means, that's that angle measure. So we want to find the degrees of that angle. So what you want to do is, think about that angle. And then first thing we always do when we're doing these kinds of problems is write out our SOHCAHTOA. Hopefully you didn't forget about this. Some old hippie caught another hippie tripping over apples. All right, so I've got my angle there. This side, the 21, that would be my adjacent leg. The 25 would be my hypotenuse. So you're going to look through sine, cosine, tangent, decide which one you want to use. In this case, we've got adjacent and hypotenuse, so I want to use cosine. So you're going to write an equation. The equation would look like this: cosine of theta is equal to 21 over 25. Okay, so this is different than what we were doing on Tuesday, because on Tuesday, you were able to put numbers inside of the parentheses as the angle measure. This time we don't know the angle measure, but we do know those two sides. So what we can do now is we can use that inverse trig to flip the input and the output, and then the calculator will tell us what the measure of theta should be. So really what we're doing is we're going to use inverse cosine, and then 21 over 25 equals theta. So remember at the beginning of this video, I said that the inverse can flip the input and the output. So when I use this inverse, this over here, this was my output, 21 over 25. Now it becomes my input, and the output that we're going to get is theta. So we've gotten theta by itself. So that will tell us the measurement of it. So what I have to do now is go to my calculator, and we're going to keep using the Desmos one. And you'll notice here we've got sine, cosine, and tangent in the Desmos calculator. If you hit function over here, that's how we can find the inverses: inverse sine, inverse cosine, inverse tangent. So you hit that function button, and I wanted to use inverse cosine, and it was 21 over 25. So I'm going to go 21 divided by 25. That thing is going to drive me insane. I've got to figure out how to fix that. All right. So inverse cosine 21 over 25. No, that didn't want to do that there. Anyways, you can see here the answer is 32.8598. If I round that, it would be like 32.860. If you're going to round to 3 decimal places. So yeah, you could just go 32.86 for this one. So theta is 32.86. I'm going to use these squiggles. because it's not equal to exactly that. I did some rounding. So 32.86 is approximately what theta is equal to. All right, let's try another one. All right, here again, I've got a theta right up here. I've got my angle that I'm trying to find. This time, I've got the opposite leg that I'm dealing with, and I've got the hypotenuse. So again, just like always, I'm going to write SOHCAHTOA and decide which one to use. So if I've got opposite and hypotenuse, that looks like sine to me, right? All right, so I'm going to do sine of theta is equal to 9.5 over 11. All right, so now I want to get theta by itself, right? So I'm going to use inverse sine to flip it. So inverse sine of 9.5 over 11 is going to equal theta. So I'm going to attach my keyboard here to see if maybe that will stop that window from popping up every time I try to use Desmos. All right, so inverse sine 9.5 over 11. Let's clear this. Okay, function inverse sine 9.5 over 11. And then I can close these parentheses if I really want to. 59.727. 59.727 is my measure of that angle. The magic of inverse sine found that for us. Again, it was, I can't remember that, 59.727. 59.727 is approximately equal to theta. I'm going to use that little squiggle because it's not an exact answer. It's a little rounding. All right. Oh, look at this. A worm is 14 feet away from the base of a tree, and it sees a bird 23 feet up in the tree. At what angle of elevation does the worm see the bird? Some amazing artist came by and drew a picture of a worm and a bird in here. So that's really helpful, but you don't need that. I know not everyone is so gifted with their drawing skills, but you can just draw the triangle. The worm is 14 feet away from the base of the tree. So this must be the tree over here because the bird's up in there. So the worm's 14 feet away and it sees the bird 23 feet up in the tree. So the bird is 23 feet up from the ground. So I've got this triangle here. It's a right triangle. At what angle of elevation does the worm see the bird? The angle of elevation means like what angle would the worm be looking up to see the bird? So that would be this angle right here. So I'll use theta again. You could use x if you don't like that theta thing. But again, now it's just like the last couple problems we've been doing. And I've got from this angle here, this 23 looks like the opposite leg. The 14 is the adjacent leg. I don't have anything on the hypotenuse. I've got opposite and adjacent. So that is tangent. So I'm going to do tangent of theta equals opposite over adjacent, 23 over 14. Okay, so again, I want to figure out what theta is. So I'm going to use inverse tangent of 23 over 14 equals theta. All right, inverse tangent 23 over 14. This worked a lot better when I used my keyboard, so I'm going to go back to that strategy. Inverse tangent, I forgot the numbers already, 23 over 14. Inverse tangent of 23 over 14. Looks like it's 58.671. 58.671 is approximately equal to theta. So hopefully what you're noticing now by this point, now that we've done 3 problems, is every time that you're trying to find an angle measure in this kind of trigonometry, you end up using that inverse button on the calculator, right? So keep that in mind. That's a helpful trick. If you're trying to find an angle measure, you're going to use the inverse button. All right, let's do one more problem together. Even though I'm having so much fun, I could do this all day. All right, find the measure of angle B. So here's angle B. All right, the problem with this is not a right triangle. We need right triangles to do all this trig that we've been learning. But what we can do is notice this is an isosceles triangle. It's got 14 and 14 on, or sorry, 41 and 41 on both sides of the triangle. So this is isosceles. What that means is if I draw an altitude down the middle, that is going to bisect this side down here. It's going to split it right in half. So I'm going to have a right triangle here where this is 9, and then I've got the 41, and I'm trying to find this angle. I put a little arc on it. I'm going to, instead of using theta this time, I'll use x. So this is x degrees. Find the measure of angle B. All right, so again, always write your SOHCAHTOA. And look at what we have. In relation to this angle, I have got the adjacent leg, right? It's not the opposite one. The opposite one would be the altitude that I dropped. So I've got the adjacent leg, and I've got the hypotenuse. So adjacent and hypotenuse, that's cosine. So I'm going to write cosine of x is equal to 9 over 41. Again, I'm trying to find the angle measure, so I'm going to use inverse cosine of 9 over 41 is going to equal x. So I'm going to go back to my calculator, and I'm going to clear this and do inverse. I have to hit that function button again. Inverse cosine 9 over 41. And it looks like my answer is 77.3196. So I'll just round that to 77.32. 77.32 is about what x equals. So the measure of angle B is approximately 77.32 degrees. All right. Well, I do hope you enjoyed watching this video as much as I enjoyed filming this video. And great job. Hope you took good notes. And Miss Rose and I will see you in a second. Bye.